This video is going to show you how to make quantitative data into graphs. So we're going to use graphs for quantitative data in this section. Just like in qualitative plots, you can do a dot plot. So we're going to go ahead and do a dot plot. The first thing that we're going to do here is we're going to read in the this data frame. So this is what this console is going to do. If you haven't already run all the checks above it, you could run all your chunks above just to make sure they've all run, just to make sure Mosaic is loaded in. Then I can run this one, and now recurrence has been created. You can see it's now over here in your environment. And we now can see what this data looks like. If I click on recurrence, I can actually bring it up. This is the recurrence of cancer. How many months after you were treated for cancer did the tumor come back? So this is just the recurrence of that. Again, I've got different tabs here that show me the different files I have open. I'm going to go back to my R Markdown file. We are now going to go ahead and create a dot plot. So I'm going to click in here. If again you don't have a bunch of spaces here, put in some spaces, and I'm going to insert an R chunk. And then I'm going to do a graph function of a dot plot. And even though this is quantitative data, I can still do a dot plot. Dot plots still work with quantitative data or qualitative. Again, just like with qualitative graphs, you need to have an explanatory variable, then tilde your response variable, tilde your explanatory variable. We have no response variable in this, so we're just going to have the tilde and then the explanatory variable, which in this case is tumor. And then you're going to put in data equals and the name of the data set. It happens to be recurrence. Again, once I start typing it, it'll show up and I can just hit tab and I'll type it in. I made a mistake, and you can see I made a mistake because I got this not found. It can't do it. It didn't show you any kind of graph. And the mistake I made was I spelled tumor wrong. I want to show you what happens when you get that. You then go back into your command and look for your error. If you get an error and you can't figure out where it is, copy this command just by highlighting it and then either right-clicking or Control-C or Command-C and copy and paste it and send it to me into an email, and I will be able to find your mistake in most cases. So I found my mistake. I spelled tumor wrong. A lot of times that's the case. Check also, because sometimes you make capital T instead of a small t. Again, R is very case sensitive. So now I've created it, and there's my dot plot. As with qualitative graphs, I can also put a title on. So back up here in my command, after the data equals recurrence, I do comma, title equals, and then type in a title. And this is recurrence of tumors and then I can again hit run and I'll put the title on there. And I spelled recurrence wrong, and it just types in exactly what I typed because it's just a quoting. So it's just going to type whatever you type. If I want to, and I don't like tumor down here on my x-axis, I can in fact make that be comma x lab for x label, and I can put in something like time for recurrence and put it in months. And then hit that. And so now you've got that down here on the axis. A lot of times, again, we don't like dot plots because if we have a lot of data points, dot plots aren't very useful. So instead, we're going to go ahead and do a different type of graph. One of the graphs we can do is what is called a histogram. A histogram will basically separate and count how many data values fall between certain time periods. It divides your time, or whatever your x-axis is here, whatever your explanatory variable is, into chunks of equal chunks of groupings, and then creates counts how many are in there. So we're going to go ahead and do that. Again, I'm going to insert an R chunk. I'm going to do a histogram, which is again a graph function. And I'm going to start typing histogram. Again, histogram comes up. I have no response variable. I just have an explanatory variable. My explanatory variable is tumor. And my data is recurrence. And then I can run that chunk. And there's my histogram. So what it did was it divided these, in this case, it just divided them up into equal groupings of, it looks like, size 1. And you can change the size if you want to, but I wouldn't worry too much about that. And it divides these up. And you can see that between 19 and 20, there were 4 tumors that lasted, that recurrence was that long. Between 39 and 40, there were 5 people who had tumors that didn't took that long to recur, and so forth. Again, I could put a title on this. So title equals something like recurrence of tumor. Titles are always good because it tells you, reader, what it is you're looking at. So remember, you always want your graphs to be understood by the reader. So make sure your graphs are understood. I don't particularly like histograms anymore. I think that they're a little, they depend on how small of classes it makes. And so it's very dependent on the classes. So we're going to use a thing called a density plot. Again, I'm going to insert an R chunk. I'm going to do a GF because it's still a graph function. We're still in graphs, so graph function and density. Now, this one, it shows up, but density is the second one down. So make sure you go down to density and then hit tab. And then again, it's tilde the explanatory variable and data equals recurrence. And again, I should have a title. Title equals recurrence of tumor. And then I can run this. And I again spelled tumor wrong. It's a lot of times what your errors are is you spell something wrong. And there it is. And you can see it kind of looks a little bit like the histogram. It's, the histogram has a lot of low, 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 and then a peak. And then we went low, 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 low again, and then a peak. And so you can see we went kind of low, we went up to a peak, came back down, went back up to a peak and came back down. What a density plot does is it smooths out the histogram. So it basically is looking at these and kind of drawing a smooth curve along it. And it's not dependent on the width of the intervals. You can actually put 2 graphs together, and I want to show you how we can do that. So I can actually take, if I want to do a density plot, I can do a density plot and do that as my first command in my R chunk. And then I put at the end of that line, this weird looking combination of symbols. It's a percent symbol, the greater than symbol, and a percent symbol. And it's what's called a piping symbol. It has a lot of different uses, but the use it is for right now is it's going to keep this line, this graph on, and then put this graph on top of it. So it allows you to put 2 graphs together. So it basically keeps this one on and then puts this one with it. It has other purposes for the piping, which we're seeing a little bit, but that's one of the many purposes. Again, if I run the chunk, now I'm going to see, here's my histogram, and then my density plot is just right on top of it. And you can see, here's my one peak, and here's my other peak. Some people like to see 2 graphs at once, so this is just a way to do that. And so you just use this percent greater than percent symbol. Another thing I can do is I can actually graph, and I want to actually show you one that has an explanatory variable and a response variable. So we're going to do a GF point. A GF point is just a scatter point. It's just plotting a bunch of points on a scatter graph. We're going to use survival, and we're going to use tilde organ. Now you're probably wondering what this is. This is the data set called cancer. I actually already have it read in. You may not yet, but I already have it read in, so I just want to show you what it looks like. Survival is how many months somebody has survived after being diagnosed with this type of cancer. So the cancer is which organ it happens to be in. Notice we go to stomach, bronchus, which is just lung cancer. Then we move down to colon cancer, and ovarian cancer, and breast cancer. So this just gives you an idea of how long somebody lives with this. Again, there's lots of data here. And so what we might want to do is look at the graphs based on that. And so we're going to go ahead and look at what this would look like for the survival, and then separated based on organ. So again, I'm going to run this chunk. When I ran this chunk, it first read in the data set, and then it created this plot. And the plot is breast has these different dots. Each dot represents a different, could be one person, could be lots of different people who had this long of survival, this many months of survival. Lung cancer, same thing. Colon cancer, ovarian cancer, and stomach cancer. So here's all of this information here that we can get from this. The problem is that like this, some of these values might have multiple values together. So you don't really know how many are there because every dot's put it right on top of itself. Every person who lived, we'll go up here to a little bit less than 1,000 days, 1,000 days. Then we've got this dot here. This could be 1 or 2 people or 5 people, we don't know. So another good plot is what is called a jitter plot. And a jitter plot is GF jitter. Again, my response variable, tilde my explanatory variable, my data set, and I can click on it. And now what it does is it actually takes and separates those out by moving them off each other. So like this data point here for breast, the second one up, it looks like, actually has 3 people who had that survival time. So it kind of just jitters, it just separates them out. It's kind of like shakes them and moves them off from each other. So you can see a little bit more about how many people are there. So you can see a little bit more information of what's going on. So that's on jitter plot's kind of nice for that, is it separates it out, can divide that up and see a little bit more information. And then we can also separate and we can do density plots again, but if I do just a density plot, I'll get everything together. If I want to look at, and I'm going to go ahead and do that. I'm going to create an R chunk. So I'm going to put a return here just so I can put an R chunk in. An R chunk, and I want to do GF density. And I'm going to do survival, so tilde survival. And data equals cancer. And I didn't put a title on it because I'm just a little lazy, but you really should put a title on. And this is the survival time for anybody, any kind of cancer. So this doesn't look great, but it gives you some idea of that. But what if I want to know, how does breast cancer relate differently to lung cancer? So I want to separate this data out based off of that variable of organ type. And so if I want to do that, I'm going to again do a GF density, tilde survival, and then I'm going to put a vertical line. And that vertical line says divided up. Think of it as a division symbol in a way. Survival divided up by organ. So we've got tilde survival, that's my explanatory variable, and then divide that up by organ. So that vertical line, kind of think of it as a divide up. And again, say what data set it is. And now what it's done is it actually divided that up. And you can see a little bit more information of how it divides up. So here's just breast cancer, here's just lung cancer, here's colon cancer, and so forth. So you can actually compare them and see a little bit more information. One last thing I can also do is, let's say I only care about the breast cancer data. So I want to take this big data set that I have, which isn't a very big data set. There's bigger ones out there. But I want to just look at the breast cancer. So I want to actually create a new data set called breast. You can call it anything you want. I called it breast because that's what the data came from. But you can call it anything you want. You can call it Billy Joe for all I care. I don't care what you call it, but make sure it makes sense to you. So I called it breast because I'm going to take the breast cancer data and put it into one place. This little arrow looking thing here, it actually looks like an arrow, means take everything you're following and put it into that breast variable. I'm going to create this new variable over here in the environment, that has everything that is in Cancer that's filtered for just the organ. So that's what that little arrow does. Then this line here just says my data set I want to pull from is that Cancer data set. And now again, you're going to see this piping thing, the greater than, the percent symbol, greater than percent symbol. It's going to pipe in this. We're going to use this data set in the next command. So this is the other purpose for it, is it basically says use it here. And then I'm going to filter, which means I'm basically taking and kind of shaking them all and only letting the ones come through that have the word breast attached to them. And I want the breast came from the variable organ. So I have the name of the organ, equal, because R doesn't like just equal, so it has double equal. And then in quotes, I said breast because I want to look for the word breast. And again, I make sure that that's the same as what I think it should. So it shouldn't be just any way of saying it. You want to make sure it actually says the same thing that this says. So notice case sensitive. And then I hit run, and it looks like nothing happened. But if you come over here to your environment, breast is now in the environment. If I click on breast, you can now see this is the same data set as Cancer, except it only has the breast. So it basically took this breast data down here at the bottom and copied this out and put it into this new variable. And now I can play around with that one. So now I have that, I can make a histogram of just that, or density plot, or whatever you want to do. I'm going to use tilde survival. My data is now the breast. The new one I just created is the one I'm going to use. And then I can, again, title it, change labels, put in a fill if I want to. And there's my plot. So this is what I can also do. There's lots of other things you can do, but these are the basic things you're going to need.